What we've developed at NASA is a technology called VISAR. It stands for Video Image Stabilization and Registration, which allows us to remove the effects of translation, rotation, and magnification in video sequences.
There are already technologies out there that get rid of jitter as far as image or camera motion. We go 2 steps further in that not only do we take out the jitter, but we take out the zoom where you've either moved closer or farther away or actually hit the zoom button in or out. And we take out rotations where you've tilted the camera a little bit one way or another. One example where this is quite helpful is a mistake I've made lots of times myself, where I'm taking a video of my child and I want to zoom in and I hit the wrong end of the zoom button and I zoom out instead and then correct and zoom back in. So what this would do is afterwards you could take that video and take out the zoom out and zoom back in and just make it so that it's steady until you continue the zoom in, and you'd never know the mistake was there. One thing we do here at NASA with scientific images is to add images together to get rid of noise so that you can get a cleaner image and can sharpen it further afterwards. We've done this with Hubble Space Telescope, where it stares at the same region of space for weeks on end, accumulating images. So that part we had. What we didn't have was a way of taking real video images and adding them together, because in order to do that, they have to all match.
One can probably think of that as taking a bunch of transparency sheets and drawing parts of a picture with pieces missing on each sheet. If you start to add and overlay each of those sequences, each of those clear sheets, you now get essentially a complete picture.
At the moment, what we've developed is what would be called post-processing, that we take video, capture it on a computer as a series of files, and then we have programs, we've written software programs that will run through those images and make another set of images where they're all stable and registered, where each one matches the other one. We can imagine, though, that this could be incorporated as a chip in a camera, where in the future all it would be a push of a button on your camera and it would do the same process while you're filming instead of through a computer program afterwards.
These kinds of capabilities would allow us to have our technology embedded into surveillance systems, scanning in real time at airport terminals perhaps, scanning in real time, maybe electron microscopy or medical imagery.
We got started in producing this product when law enforcement came to Marshall Space Flight Center asking for help with a crime scene they were investigating, where they had home video related to this crime scene, and they wanted to get good images out of it and thought they could do better than what they were getting out of their labs. And so they came to us and asked for our expertise in help in this, and we were able to come up with a process that did indeed produce images and video that were quite helpful for them in this particular crime investigation. This video sequence from NASA shows translation in both the horizontal and vertical directions, as well as some changes in zoom. VISAR keeps the shuttle well stabilized in the right-hand panel. Even a 2x zoom within VISAR shows little residual motion. This sequence is representative of a handheld home video. The VISAR stabilization on the right removes the jitter as well as the change in zoom at the end of the sequence. This example is from a remote-controlled surveillance vehicle. The motion of the horizon can make the operator nauseous. VISAR stabilizes rotation and zoom as well as translation. The resulting steady horizon would provide a more relaxing focal point for the operator. These infrared images can uniquely identify an individual. The VISAR stabilized images could be used in automated identification. Brightening a single image of a nighttime scene just brings out the video noise. Adding together VISAR stabilized images from just 1 second of video produces a much clearer image. This simulation of a chase scene shows how identification is facilitated by the VISAR stabilization. We can see that the plate starts with a 4-7 and ends with a 2. Video noise is reduced by averaging together the registered frames. This then allows for image deblurring to reveal the full plate number, 47FG182.